All right. Boom. So, law of cosines. Remember your three law of cosines. Let's slide that down now. So, a squared equals b squared plus c squared minus 2bc cosine of a, or alpha. B squared equals a squared plus c squared minus 2ac cosine of beta. And c squared equals a squared plus b squared minus 2ab cosine of gamma. All right. So when you have side angle side, just like the good old weebs, plug and chug, baby. Plug it in, find the answer, take the square root of that answer, and you're golden. Okay? Then you use law of sines. Okay? So side angle side, super easy. Okay? The first problem on your homework will be a side angle side one. So let's go through that quick, just to kind of refresh. You had these yesterday. So a side angle side one, here's 7, here's 11, here's 99.4. So we want to find b first. So b squared equals a squared plus c squared minus 2ac cosine of b. Okay? So then you grab your calculator and you say, Mr. Calculator or Ms. Calculator, depending on your preference, 7 squared plus 11 squared minus 2 times 7 times 11 cosine of 99.4. Enter. And it's some huge number, and there's no way this side could be 195.15. So you go second square root of the answer. And 13.9697. And that would make sense as 13.9697 because it has to be bigger than 11 because 99 is an obtuse angle. So it's the biggest angle of the triangle. So this should be the longest side. So that makes sense. 13.9697. Once you get that, to find this, you can use law of sines. The sine of gamma over 11 equals the sine of 99.4 over 13.9697. So you take this times this divided by this. So 11 times the sine of 99.4 divided by 13.9697 is 0.77, and you go second sine of the answer, because when you're looking for an angle, it's the inverse sine. So you get 50.97. How many decimal places? One decimal place. So 51.0. And then add these two up, so they add up to 150.4. Subtract that from 180. So it's 29.6 is the other angle. Look good? That's what we did last time. Okay? Side, angle, side. Now, is side, side, side. When you have side, 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 you have to solve for an angle. And I will show you the difficult way first, and then I'll try to simplify it for you. So, if A is 25.6, B is 13.6, and C is 24.6, you always always find the side of or the angle opposite the biggest side first, or you will have a very good chance of getting them wrong. Okay? If you have side, 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 find the biggest angle first. Because what do we find out in the law of sines? It can either be one number or 180 minus that number. So there's two answers for the same angle. Okay? So if you find some other angle and use law of sines, you're going to get thrown off. Okay? And I'll show you a little way of doing this too in a little bit to make life a little easier. But that says 13.6, right? Yep. My computer has some issues sometimes. All right. So since 25.6 is the biggest side, we go 25.6 squared equals. So we're going to do the a squared equals b squared plus c squared minus 2bc cosine of alpha. So b is 13.6 squared. C is 24.6 squared minus Mr. Rierschbach 2bc cosine of alpha. Okay, now if we square everything out and multiply everything out, this is what we're going to get. 25.6 squared is 655.36. 13.6 squared is 184.96. 24.6 squared (605.16). 2 times 13.6 times 24.6 equals 669.12 cosine of alpha. What do you think the next step is? How would you get cosine of alpha all alone? Would you add this to this? I sure would. $790.12. That looks about right. So should we take 790 minus 669.12? Yep. Medora says no. Who should we trust? Medora or Jackson? Don't? Yeah, we have this multiplied. So if you think about it, and Jackson, you know how many people make that mistake every single year in this class? A lot. But if you think about it, if 6 equals 2 plus 3x, how do you solve that? You minus 2. You don't add 2 and 3 together. You minus 2 first, right? So since we have this, we have to subtract 790.12 from each side. And I'm not going to do that in my head. 655.36 minus 790.12 equals negative 134.76 equals negative 669.12. And then if we divide by negative 669.12, we get 0.2014 So to get alpha alone, we move the cosine to the other side, so it becomes the inverse cosine of 0.2014. So alpha equals 78.38. So that's 78.4. Once you get done with that, I mean, you could do this all over again for another angle, but why do all that work when you just can have the law of sines to say sine of 78.4 over 25.6 equals the sine of, let's just say, gamma over 24.6. And we'll find gamma, then we'll find beta. So then it's just simply 24.6 times the sine of 78.4 divided by 25.6, and then inverse sine of the answer is 70.3. Okay. And if those two add up to 148.7, 180 minus that is a 3, a 1, a 3, so it's 31.3. Little bit of work over here for this, isn't it? What if I make it calculator friendly? That'd be a lot better, right? How do I make it calculator friendly? Well, we take these a squared equals b squared plus c squared minus 2bc cosine of alpha, and we change the formula to get just alpha alone. Okay, how do I get alpha alone? Well, I took a squared minus b squared. Come on. I can take a squared minus b squared minus c squared equals negative 2bc cosine of alpha, right? And then I divide by negative 2bc, right? So these cancel. And then I take and get rid of my cosine and put it as an inverse cosine over here, right? So the way you put it into your calculator is this. I'm going to write it down. Yeah, I'm going to write down on the notes the calculator friendly version of it. So cosine, and then it's going to slap inverse cosine, and then it's going to slap in a parenthesis. You're going to slap in a second parenthesis. And then it's going to be whatever A is and square it, minus whatever B is and then square it, and whatever C is and then square it. And then you're going to close one parenthesis. You're going to push your divided by sign or your slash, whichever, if you got a graphing calculator, is the slash, divided by. And then you're going to start a parenthesis and go negative 2 times B times C, close a parenthesis, and close the parenthesis again. That's calculator friendly. What does that find you? That finds you alpha. So what would find beta? Well, between these formulas, I know you're writing, so I'll take a break for a second. Okay, I'm going to fly up here once for a second. What's the difference between the top formula and the second formula? What's the only difference between these two? Wherever there's an A up here, it's a B. Wherever there's a B up here, it's an A. We just switch the A's and the B's, and then switch alpha to beta. So that's what you do in your calculator ready format. Your calculator friendly one is beta equals the inverse cosine of wherever there's an a, there's a b, so it's b squared minus a squared minus c squared divided by parentheses negative 2ac. Close the parentheses. And gamma would be what? Inverse cosine of c squared. Because whatever this one is, it goes right here, and then you never use it again. If you can remember that, you can memorize this. Because am I going to let you have the calculator ready on a note card for this test? No. You got to know it. So there's a way to memorize it. Whatever this is matches this and never use it again. So what are the other two letters involved? Well, I know there's an A involved and a B involved. There's an A involved and a B involved. That's calculator ready. So when I use my calculator on a problem, and I'm going to go to the next problem now, okay? Everybody got these written down? Those of you taking notes, those of you who refuse to take notes, you just got it in your heads, right? Okay, because I know there's some of each in here, okay? This is a side angle side one, so I'm not going to do that. That's calculus. Anybody want to do some AP calculus here? No? Okay. We'll do this one. We'll do this one, calculator right here. I'm going to do something here. Just a second. Bear with me. Boom, boom. I want to go like this, and like this, and like this. Okay, now I'm ready. Jeez. As soon as I flip it, it moves. All right. So if I want to find alpha, it's the inverse cosine of what? A. So it's a squared minus b squared minus c squared divided by negative 2 times 12.3 times 13.1. So, turning on my calculator, it'll be inverse cosine of, add an extra parenthesis, 20.2 squared minus 12.3 squared minus 13.1 squared divided by negative 2 times 12.3 times 13.1. Boom, boom. Boom. And it'll give you an answer. Pretty sweet, right? You know what's even sweeter? If you have a calculator that remembers the last problem, like a graphing calculator, you go second, enter, and it shows up, right? Then you just arrow over and switch around the numbers, okay? So if I want to find B now, all I do is just arrow back and make B where A is and A where B is, okay? So this is 12.3. This is 20.2. Don't change that one. This is 20.2. Don't change that one. Press enter. Oh, sweet. That just saved how much time compared to doing all that math? Okay, this is 36. Okay, come on. Whatever. That's 36.0. You subtract from 180 to find the other one. Okay? All right. Something really weird's happening to OneNote at times. All right. Then your last few problems today says determine the number of triangles with the given parts. I know you people. I know how you work with Math Excel. You'll guess on this, but there's ways to figure these out. But I know a lot of you will guess, okay? A is 7, B is 3, and beta is 15. If this is a 15-degree angle, and this is 3, and this is 7, okay? Is there, since that's an angle, a side-side angle, I almost said it backwards, naughty me. How many triangles do you think there's going to be? Probably 2, okay? Now, if you add these 3 angles up, what do they add up to? More than 180. How many triangles are there? 0. Okay. This one, you have a super big side and then tiny here. Okay. So you could go ahead and draw that out and go, well, this is a super big angle. How many obtuse angles can you have in a triangle? 1. So there can only be 1 of that. And then this one, you can kind of figure that out. Here, when you have this problem, you draw it on your paper. If this is 4.5, this is 4.5. If this is 4.9, this is 4.9. If this is 3.1, this is 3.1. They're all radii of the same circle. So this radius is 3.1 no matter where we're at. This one's 4.9 wherever we're at. This one's 4.5. So then you figure out the sides of the triangles. This was 7.6. This is 9.4. And this is 8.0. And then these are the 3 sides of the triangle. And you're just told to figure out the angles. Well, it's a side, side, side problem, right? So use a shortcut to the law of cosines within your calculator to figure it out. And the last one, straight path between A and B. It also intersects with C down here. C is 112 degrees. We want to know from A to B if BC is 1.7 and AC is 0.4. Well, isn't that side angle side? So that's the calculator ready from the start problem. Okay? Or the side angle side. Throw it into your calculator and take the square root of the answer problem. Okay? So there's 10 problems, which will be plenty of work to keep you busy for quite a while today. We're only going to do one section today. You have an hour basically to work on this. If you didn't get the last assignment done, get that done. And then you have this assignment, and that's it for today. We'll do one section on Monday. We'll get ready for a quiz Wednesday. And in our 45 minutes Friday, the day after a football game, I know, but in our 45 minutes Friday, we'll take a quiz. Okay, there you go.